All right, chapter 13:10, we're going to be talking about compound probabilities. And we touched on this a little bit in 13:8. And honestly, the equation that they gave you for 13:8 was, I don't know, kind of confusing. They give you a different equation for it in 13:10, and I think this is the much easier way to do it. So a compound probability is anytime you have a probability that includes more than one event. So rolling a dice and tossing a coin, or drawing a card and spinning a spinner, okay, doing it together. So here's the equation that you need to write down in your homework or in your notes. And the way you figure compound probability is you break it up into single events, and then you just find a simple probability for event 1 times the simple probability for event 2. And then that gives you the compound probability. You reduce your fraction and you get your answer. So much simpler way to do it than we were shown in 13:8. So hopefully this clears this up and makes this much easier to do. So if you look here, we are rolling a number cube and we are spinning a spinner. So when we roll a number cube, what is the probability of rolling a 2? Well, a 2, there's 1 out of 6 chance. And then spinning a spinner, again, we look at that as a single event by itself. If we spin a spinner and get a green triangle, well, there's only one green triangle space out of 8. So that is 1 out of 8. And then you multiply across the top, you get 1, multiply across the bottom, and that is your compound inequality or compound probability for that event. If you look at number 3, rolling a die and getting a prime number, well, on a die, the prime numbers are 2, 3, and 5. So there's 3 out of 6 available. And if you look at the spinner, it says quadrilateral. Well, look at your spinner. Triangle is not, circle is not, a rhombus is, a rectangle is, a triangle is not, a circle is not, a trapezoid is, and a square is. So that ends up being 4 out of 8. Multiply across the top, multiply across the bottom, and then reduce, and you get 1/4. So that is how you do compound probabilities with a much simpler equation than what we did during 13-8. All right, so now everybody can kind of jump back in class with me. We're going to go ahead and go down to this section. And this is the section I was struggling in yesterday because I could not get the answer that was in the answer key, and I couldn't figure out why. And thankfully, Jayla brought it to my attention that I was not reading the directions. And I always tell you guys, read the directions, read the directions, read the directions. And then I did not read the directions. So I was talking about you have a bag of marbles. When you draw one, now you have one less marble in the bag, right? You don't replace it, and then you draw another one. So that changes your probability. Well, that's great if the directions say that you are not replacing the marble. But if you notice, what does it very specifically say in the directions? Once a marble is drawn, it is replaced. I did not read the instructions on this section, and so I was doing it not replacing the marble. And we will do that down here. Once a marble is drawn, it is not replaced. So I was doing it the not replaced way up in the replaced section, which is why I was not getting the same answer as the answer key. So if you look at this section right here, this is the replace section, which means you draw your first marble out, then you put it back in, shake them back up, and you draw a second marble out, and we're going to find the compound probability of drawing first a purple, then a red. All right, so draw one. First of all, we need to know we've got 5 yellow marbles, 1 purple marble, 3 green marbles, and 3 red marbles. So how many marbles do we have in total? 5 plus 1 plus 3 plus 3 is 12 marbles. Okay, so we have 12 marbles total in the bag. If we have 12 total marbles in the bag, okay, what is the probability just on the single draw of drawing a purple marble? How many purples do we have in all? Purple, we have 1. So a 1 out of 12 probability of drawing a purple. Now, we drop that marble back in the bag. So how many do we have in the second draw? We have 12 again, right? Because we replaced the marble that we just pulled. Now we shake the bag up. What is the probability of drawing a red? 3, because there's 3 red marbles. So the probability of the second event as a single event is 3 out of 12. Now we multiply across the top, multiply across the bottom. And when we reduce this, We divide 144 by 3, we divide 3 by 3, and we end up getting 1/48, which was the answer in the answer key that I could not get to yesterday. Okay, it's because I missed that this is a replacement problem, and replace and not replace will change your answer. Okay. All right, now I'm going to erase kind of the little bit of underlining I did for that one so that we can start fresh. I want to do number 8 with you. 2 red marbles in a row. Okay, and remember we're replacing. So the first probability is drawing 1 red marble on our first pull. Well, how many red marbles are in there? 3 out of 12. Okay, so that is our probability on the first pull of pulling a red. We replace that marble, shake it all up. What is our probability of drawing a red on the second pull? Still 3 out of 12 because we replaced that marble. We still have 12. We still have 3 red marbles in the bag. Okay, so we multiply across the top, multiply across the bottom, and then we reduce that. Well, check it and see if you divide 144 by 9, they're both divisible evenly by 9. We get 1/16. Okay, are we good on that? Now I want to focus on the not replace, because this is where this is what I was trying to do yesterday in that 5 through 10 section. So if we do not replace the marble, okay, think about, and our numbers change here. So it tells us that we have 4 yellows, right? So we've got 4, whoops, kind of highlight these. We have 4 yellow marbles. We have 3 purple marbles. We have 1 green marble. We have 1 white marble in the bag. So how many total marbles do we have in the bag? Jada? 9. All right, so we have total of 9 marbles. Now this is a do not replace, which means once we draw our first marble, we set it off to the side. So number 11 says you draw a purple first, then a white. So on the first draw, what are our chances of drawing a purple? 3 out of 9. Remember, we're at the 9 one now. We're on different, we've got different marbles in this second bag. So it's 3 out of 9, right? That's our chance of drawing a purple. Now, we do not replace the marble. We set it off to the side. And now what is our chances of drawing a white marble? 1 out of 8. Because we didn't replace the marble. Okay, we set it off to the side. We only have 8 marbles in the bag for the second draw. And then we multiply across the top, multiply across the bottom, and we get 3 out of 72, which reduces to 1/24. And that is the compound probability for number 11. Okay, easy enough on that. I do want to do when you have 2 marbles the same color. Okay, so I want to do number 14 with you. 2 yellow marbles in a row. Yes. I didn't take 3 out. I drew, which are you talking about number 11? Yeah. I didn't pull 3 marbles out. On my first draw, I drew out a purple. I had 3 purples, right, in there, but I only drew 1 purple out. But my chances of drawing a purple are 3 out of 9. Those are just my chances of drawing. I didn't draw all 3 out. That was just how many I had in the bag as a possibility. Okay. Make sense? Okay. Let's look at 2 yellow marbles because I really want to, when you're not replacing, I want to address when you're drawing 2 of the same color. So probability of my first draw, I've got 9 marbles in the bag. I shake them up. What is my probability of drawing 1 yellow marble? 4 out of 9. Good. All right. I take that yellow marble. I set it off to the side. Okay. Now I shake up my bag again. First of all, before I even do anything else, how many marbles do I have left in the bag? 8. Okay. What is my probability here of drawing a yellow? Nope. Oh, yes. Sorry. I was thinking there were 3 to begin with. Yes. Because I took my first yellow marble out and I set it to the side. Now there are only 3 yellow marbles in the bag. So when you have a double color being pulled, you have to account for the fact that you pulled one of your yellow ones out the first time. That means there are only 3 left in the bag for the second pull. So do you see how you do replace and do not replace much differently? Yes.
Why aren't there 2 yellows getting taken out? Because it says 2 yellows.
In a row. So first pull, second pull. You only pull one at a time. Okay, it says find, it says there are blah, blah, blah in the bag. Once a marble is drawn, so you one at a time, right? So yes, you pull 2 out, but shake up the bag, reach in, pull 1 out, it's a yellow. Now reach in again, you happen to pull a second yellow out. What's the probability of pulling 2 yellows back to back? Not reaching in and grabbing 2 marbles at a time. Yes. And then we real quick, let's reduce this and then I'll answer your question. 1/6. Now, what was your question? What was your question?
What's the probability of pulling 3?
3 in a row. Let's figure it out. So we would keep the 4/9. We would keep the 2/8. What's the probability on the next pull? Oh, sorry, that's supposed to be 3. I'm bound and determined to say there's only 3 marbles in that bag. All right, so we had 3 out of 8. What's the probability on the next pull of pulling another yellow? 2 out of 7. Because now we only have 2 marbles in the bag that are yellow and the bag's down to 7. So you would just multiply across the top, across the bottom. What's the probability of drawing 4 yellow marbles in a row? It would be 1/6. Because on that 4th draw, you've only got 1 yellow marble left and you only have 6 in there. You'd multiply across the top, multiply across the bottom.
Could you go to 0?
No, because you can't have a probability of, I mean, the probability would be 0 of, yeah, because if you, what's the probability of drawing a yellow when there are no yellows in there? 0. No. I mean, if it asks you that, your answer would be 0 because you literally have a 0 probability of drawing 5 yellow marbles in a row when there's only 4 in the bag. So it would actually make your whole problem go to 0 probability. Make sense? All right, that's the difference between replace and not replace. And that was where I was jamming up yesterday. I just want to do one of these. You draw a card from a standard deck of cards, which we know that's 52 cards, right? And you find the probability of each outcome. So a red card or a club. Well, how many red cards are in a deck of cards? That's diamonds. There's also hearts. So that's 26. How many clubs are there? 13, right? Because you have 13 diamonds, 13 hearts. Those are both red. Then you have 13 clubs. So what is the probability? Well, that would be, add that up, you would be 39. So you would have a probability of 39 over 52, which reduces to 3/4, because 3/4 of the deck is either red or a club. That leaves just spades that you can't pull, okay? How about the probability of a 7 or a 9? How many 7s are there in a deck of cards? 4. How many 9s are there in a deck of cards? So there's 8 cards in a deck out of 52. So that would make that 2 out of 13 when you reduce it. Good?